Most people saw it as art. A humanoid robot calmly threading a needle, stitching delicate embroidery on soft fabric with near-perfect precision. But what TARS Robotics just demonstrated is not about embroidery at all. It's about solving one of the hardest unsolved problems in robotics. And once you understand that, this demo suddenly becomes very serious. Before we go further, if you follow humanoid robots, real-world AI, and breakthroughs that actually matter, make sure you subscribe now. Short, focused updates like this are what this channel is all about. So what exactly did TARS unveil? At its recent Needle Kung Fu Tech debut, TARS showed what they claim is the world's first autonomous embroidery robot. Not a fixed industrial embroidery machine, but a general-purpose humanoid robot performing hand embroidery on flexible fabric, with sub-millimeter precision, threading a needle, managing tension, adapting to fabric movement in real time. These are tasks humans perform instinctively, and robots have historically failed at. Why? Because soft materials are a nightmare for automation. Rigid objects are easy. A bolt is always a bolt. A metal panel doesn't suddenly wrinkle, stretch, or shift unpredictably. Fabric does. This is why even in 2025, textile work, wiring harness assembly, cable routing, surgical suturing, and fine motor repair tasks are still largely done by humans. Robots simply lack the combination of perception, force control, and adaptive intelligence needed to handle them reliably. That's what makes this TARS demo important. According to the company, the breakthrough comes from what they call a data AI physics approach. Instead of training a robot on one narrow task, TARS focuses on learning generalizable physical skills, how objects deform, how force should change dynamically, and how to react when the real world doesn't behave like a simulation. This is similar in philosophy to what companies like Figure AI, Tesla, and 1X are pursuing, but applied to a far more delicate domain. For example, Tesla Optimus is currently impressive at structured factory tasks like sorting, walking, and object transfer, but soft material manipulation remains limited. Figure 03, on the other hand, has shown strong progress in dexterous grasping and tool use, but still hasn't publicly demonstrated this level of fine fabric control. Unitree's humanoids, like the G1, excel in agility and motion, yet precision manipulation at this scale is still largely unexplored territory. That's why embroidery matters. If a robot can reliably stitch soft fabric, it means it can potentially handle flexible cables in electronics, assemble complex wiring looms, perform surgical-grade suturing, repair clothing, upholstery, or composite materials, work in textile manufacturing without rigid fixtures. In short, it unlocks entire industries that automation has struggled to touch. And here's the bigger picture. This isn't about replacing artists or craftsmanship. It's about proving that humanoid robots are moving beyond scripted motion into true physical intelligence. Robots that don't just move, but feel, adapt, and correct themselves in real time. That's the same missing capability holding back household robots, elder care assistants, and service robots from mass adoption. So while Needle Kung Fu might look poetic, it's actually a signal that humanoid robots are quietly crossing one of the last major barriers between controlled demos and real-world usefulness. And the companies that master soft material manipulation first will define the next decade of automation. If you want deeper breakdowns like this, no hype, just real progress, subscribe and stay tuned. Because the humanoid robot race just got far more interesting.